Okay, more details about other components of a query. First, filters. Okay, we can define filters to restrict query results based on a characteristics or number of characteristics. Okay, and again, these filters, they can be reused by other queries. So we can also define restrictions for each characteristic, such as year is equal to a value, 2010, or a variable. Okay. Similarly, for division, you can enter a value, or you can use a variable that you defined before, or somebody else has defined before. Like I said, variables, they can be reused in other queries. Next, conditions. We can also define for our queries. Conditions are similar to filters. Okay, they also restrict the query outputs or results. And the difference is that conditions are applied to key figures. A good example is the top 10 products or top 10 materials. It's a condition that we can define. Okay, and when we want to define a condition, we can create a new condition from the conditions screen area. Okay, and then from there you can select a key figure such as material, and then you select an operator, for instance top, and then you can define top 10, top 20, top 100, and so on, or an operator like greater than equal to or less than whatever. You can define the value, and then there is your condition on the key figure. Okay. Exceptions can also be defined for our queries. Okay, and exceptions are similar to conditions, and because they are applied to key figures. Okay, but the difference is that instead of restricting outputs like in conditions, we will just highlight all key figures, okay, based on certain criteria. So using exceptions, for instance, we can define green for cells that are greater than a certain number. Okay, let's say 1,000 US dollars or 1 million US dollars, and so on, and then red otherwise. Okay, so this way the manager can get a quick picture about where went wrong. Okay, which division or what year your key figure is not meeting the target, and so on. Okay, and we can create an exception by clicking the exception icon on the toolbar, and then you select the key figure like sales or cost, whatever, and then define the alert level, operator, and value. Okay. Okay, a review question for you. Next, we're going to talk about the properties of query elements. So after we define our queries, we can then set the properties for components, for the components, including the query itself, have properties that can be configured to determine their behavior. Okay. For characteristics, the book has straightforward description, so you can take a look at that. And similarly for queries, they are also pretty straightforward in the book, except I like to call attention to the planning tab, where you would set the property so that a query can start in change mode as opposed to read mode. Okay, because for most queries, as some of you probably know, is that we want to use a query to display data, right? In other words, we use a query to read data from the system. But there are also certain queries that can be used to input data to the system. Okay, so the one exception is we can start a query in change mode to create an input-ready query. Okay, which can be very useful for planning purposes, which we'll talk more about in a separate chapter on integrated planning. Okay, so for most queries, you don't have to worry about the planning tab, but if we are doing integrated planning, then we have to set the property accordingly. Finally, the key figure properties are more involved, so we'll talk more about on the next few slides. Okay, key figure properties that we will define in the Query Designer. First is the aggregation tab. Okay, where you will set how do you want to aggregate a particular key figure. Okay, by default, key figure is aggregated using the standard methods such as sum that I talked about earlier. Okay, and if you want to use an exception aggregation, then you can define there in the aggregation tab. Then if you are talking about a restricted key figure, okay, you can further define constant selection for that particular key figure. Okay, constant selection will be used if you want to have a restricted key figure working kind of like a baseline. Okay, if you want to compare this key figure to other key figures in your report, then you can set it to be constant based on a particular selection. Okay, like if you want to compare the sales in your home country, let's say USA, with other areas, then you can define country equals USA, and then you can use constant selection to compare the sales figure in this area with other areas. The planning tab also needs to be set up properly if we are doing integrated planning. Then for the key figure, we will define that as input ready key figure. Okay. And finally, for the calculations tab, there are two variations, okay, that we can define. I mean, we don't have to define anything there actually, but for certain situations, we have to define either as calculate result as or calculate single value as, which I will explain in more detail on the next two slides. All right, first, calculate results as. Okay, now this is part of our local calculations. Okay, that means when your query is run, BW will locally recalculate the results to replace a totals line. Okay, now why is that necessary? Okay, for instance, you have several key figures defined in your query. Okay, like sales, units sold, and then ASP. Okay, average selling price. So, for instance, in year 2010, you have $2,000 of sales, 100 units. So your average selling price is $20, right? And then 2011, your sales is 2,700, and you sold 150 units. So your average selling price becomes $18. All right. Then when you display those three key figures in a query, then in the report, now by default, the aggregation is sum, right? So sales is added up, so is units sold. But how about ASP? Okay, do we want to add up the two average selling prices? Well, probably not, right? Because if you add them up, $38, that is actually wrong. That's not the average selling price for those 2 years. Okay, so instead you want BW to recalculate the average selling price locally when the query is run. Okay, so in this case, we probably want to define that as the average as opposed to standard aggregation, which is sum. Okay, so that's local calculations using calculate results as. Another variation of local calculations that is necessary is known as calculate single values as. Okay, now this example was taken from actually SAP library. Okay, they have this example that shows, let's say, I guess this is a car company, right, or dealership. Okay, they have different types of cars, BMW, VW, Mercedes, and so on. Well, I guess a German company. And they also have different markets, right? Germany, England, France, and so on. Okay, so this table shows the number of cars that were sold in different markets. Okay, so nice two-dimensional table shows our sales results. Okay. However, we can also display the same results in different ways to make it more maybe meaningful or easier to interpret whatever based on user requirements. Okay, for instance, one is that in the middle of the slide, it shows that we can normalize the results or normalize the data based on overall results. Okay, and that means basically we calculate a percentage for each sales number. Okay, so rather than raw data, we provide a percentage for each market, for each car, for easy comparison. Okay, so this way we can probably tell, for instance, France, for BMW, France, you have more than twice than England, which is not quite twice as in Germany and so on. Okay, so maybe some people will find the percentage easier to work with. All right. Still, another way to represent the same data is to use some kind of ranking. Okay, so we can use a ranking function to display the same raw data. So now this way, we can have a ranking of all the markets and all the cars. Okay, so for instance, BMW in France is ranked number 1 in terms of our sales. All right, and then Mercedes in England is number 2. Okay, and then followed by VW in France and so on, which has a tie with VW in England actually. Okay, so this way we can again easily compare results from different countries, from different models and so on, or brands using a ranking. Okay, so this is known as calculate single values. So we replace each raw number with either a percentage or a ranking. So this is also a type of local calculations that we can ask BW to perform for certain key figures.